Yeah. All right. Hello, everyone. Welcome to week 10 or chapter 10 of Analyzing Baseball Data with our book club. Good to have everyone back. I'm going to start sharing my screen for my notes. All right. Can everyone see that? This week, we're exploring Streaky Performances. Let's just make sure. Okay, great. Um, just a few objectives here. Um, we're going to be looking at hit streaks and how to calculate them um, for individual players. We're going to take a look at if streaks are unusual or not, um, and compare it to randomness. And then we'll take a look at some other measures to understand batter performance and streakiness. The last section we'll get into some StatCast measures and specifically launch speed for the batters. Okay. So as a introduction, um, this is Joe DiMaggio, um, Hall of Fame baseball player for the New York Yankees in the 20th century. In 1941, he's famous for um, getting the major league record for a hit streak. He had a hit in 56 consecutive games. Um, no one else has come close really since. A few people have gotten to the 30s. I think maybe Pete Rose has he had a hit streak of in the 40s. Um, but a lot of people consider this record untouchable. And here he is kissing his bat in 1941, the year he set the streak. Um, and funny enough, his hit streak ended at 56. Um, I'm not sure if it was true or if it was like a fabrication, but uh, allegedly he had a deal with Heinz 57 that if he would have extended it to 57 hits, they would have like given him like $10,000 or something. Um, I just thought that was funny. So the first section of this dives into um, Joe DiMaggio's great streak. Um, the play-by-play data is actually now available on RetroSheet, and you can get that via the Baseball R package. But we gather our data from Baseball Reference in our case, and utilizing the books package to get that. So we read it in DiMaggio 1941, just to check that the data is correct and we're analyzing it correctly. We calculate his season average, 357. That matches his actual batting average, so we're good here. Um, Interestingly enough, uh, this wasn't the top average for 1941. Ted Williams batted 401 in that year as well. Um, so the book says a hitting streak is commonly defined as the number of consecutive games in which a player gets at least one base hit. Um, However, I can't remember if the book actually covers this caveat. Um, there, from the MLB official rulebook, a consecutive hitting streak shall not be terminated if a batter's plate appearance results in a base on balls, hit batsman, defensive interference or obstruction, or a sacrifice bunt. A sacrifice fly shall terminate the streak. So if a player, say, pinch hits and gets a walk or any of these occurrences, their streak continues. And I guess it doesn't only have to be pinch hitting. If all of their plate appearances result in any of these scenarios, the streak also continues. So just a little caveat. I suppose when we do calculate the hit streak, this is simplifying it a bit, but I don't think we have to really worry about it in our case. Yeah, I think I read somewhere that this rule like came up in one of like Derek Jeter's longer hit streaks. So it's rare, but it does occur. So here we take Joe's data and calculate whether or not he had a hit in a particular game. Printing it out here, we can see he started out this season with 8 hits. That's pretty good. Followed by a 3-game stretch where he was hitless. So yeah, that's kind of just visualizing all the hitless games and the hit games. What if we wanted to calculate all the hitting streaks for a particular player? So calculate this 8-game hitting streak, followed by a 3-game, 2-game, et cetera, et cetera. We created this this new function. I can't remember where this must be from the base package RLE. We make a new function to gather those streaks, and we'll use that throughout the rest of the chapter. So we take that data, run length encoding. Thank you, Ricardo. We take Joe's data and then calculate the streaks. Values equal 1. That's when he gets a hit. So here we can see all his streaks over the 1941 season. Interestingly enough, his 56-game hit streak was followed by a 16-game hitting streak. So that's like pretty good. Maybe more interesting is taking a look at when a player goes hitless. DiMaggio's longest hitless streak in 1941 was only 3 games. We do the same thing, except this time with values equal to 0. So yeah, based on these hitless streaks, he had a pretty good 1941 season. 3 was the most, and then only streaks of 2 and 1 without hits. So during these hit streaks, we may be interested in like what does their performance look like during these hit streaks. DiMaggio's overall batting average was 357 for the 1941 season. What does it look like say like during the hit streak, what does it look like throughout the season? And this is what we'll do in this section. So we'll create a new function, moving average, featuring roll mean and roll sum from the zoo package. Also note they use the transmute function, but that has since been superseded because you can perform the same job with mutate keep equals none. So yeah, they both do the same thing. I still used transmute in this case. So we have this new function for moving average, getting the game and the average as well. The width, they call it a windowing function or a width function. That's the size of the game window that we want to set. In this case, we calculate a moving average with a 10 game width, and then plot and utilize ggplot to plot his season average as a horizontal line, as well as games where he got a hit along the bottom. So I thought that was this GM rug function I particularly thought was pretty cool as well. Note if you're following along with the book's code, just remember that they use the CRC blue color throughout the book, so just make sure you have that defined if you use that color. So we take that data with the 10 game windows, we plot it, and during you can see his 56 game streak in the middle of the season. You can see he got hotter and hotter during his streak. It actually peaked, I guess, batting average wise towards the end of his batting streak. So like without this game, he was pretty hot during that period. And then towards the end of the year, he cooled off a little bit, batting average wise. Any questions on the first part of the chapter, or comments?
All good so far from this end.
The only like, or one of the things that I was thinking about while going through this chapter was just like thinking about I guess, like the run environment. You know, if DiMaggio is batting 357 and Williams is batting 401, like the league as a whole is the league-wide batting average is probably pretty good. And then compare that to like the modern day, the 2020s. Batting averages are much lower. Pitchers are like every pitcher is throwing like 100 miles per hour. So like that could be a reason why batters aren't getting those longer hitting streaks like in the past. But I guess 56 is still like, that's still pretty spectacular, even in that era, and for the whole baseball
That-
era.
That's almost a third of the season.
Yeah, yeah.
You know,
um,
just hitting continuously. I mean, that's big. I remember
um,
that Pete Rose got close. In f-
yeah.
in fact,
Um,
I don't remember the name, but the one that had the record, the second record of the hitting streaks, I think it was 44, 43, 44, and he surpassed it. Okay, so he was going there, but then uh, it stopped.
yeah,
Okay, but yeah, he was, I think I don't know if he's still, but I think he's the second one. With the hitting streak. We have to check that.
yeah. If you want to, I think there's like a Wikipedia article of not just there's a hitting streak article. There's also like streaks of um a lot of other different stats in MLB. I think like
Right.
home runs, streaks of getting on base. Um,
Exactly. Yeah, yep.
yeah.
In the blog post that Derek, posted, Jim Albert talked about strikeouts. No strikeouts.
Oh yeah, yeah.
Mookie Betts had it was a lot. It was 78 plus 51 because it was between seasons.
Oh,
Okay.
okay.
Finish 78, and then he got 51. So between six consecutive seasons, he got about 128. That's good.
Yeah,
That's
that's
good.
good.
With no strikeouts. At least he's making contact with the ball.
Yeah, that's pretty good.
Yeah, oh yeah. Oh yeah. Oh yeah.
Um, yeah, so that's like I guess this chapter specifically focuses on hits. We'll get into the bat speed as well later. But there's a lot of different ways you can analyze like streakiness with other stats as well. Right. Um, so in the next section, they take a look at uh, the at bat level. The previous section, we were just focused on um, the game by game picture. Um, but with richer sheet, we can take a look at the at bat level and kind of similarly, instead of like a 10 game window or however long we want to look at, we'll look at like an at bat window. I think specifically like 30 at bats for a given window for a given player. And for this exercise, we'll take a look at the 2016 data, um, specifically on Ichiro, the true hit king, combined MLB and Japan. Um, he has the most hits. So we will filter for Ichiro's ID, um, and then do some data manipulation to get his hits along with the date and at bats. Um, and then, like before, we'll utilize the streaks as well. Um, so instead of consecutive games with a hit, this is consecutive at bats with a hit. Um, so here he got a hit, um, got out the next at bat, got a hit out. Um, so mostly one, like streaks of one, hit and out. But he got up to five hits and five consecutive at bats. Um, so that's kind of interesting. Um, we may also be interested in uh, the opposite as well. What do the streaks look like when he goes hitless? So similarly to before, we look at values of 0. And here we might get a better idea of streakiness or when he goes cold during a season. There's quite a few higher digits here, and then some streaks of 11, 12, 18 is, is actually his highest streak without a hit. If you pipe it to table, you get this result.
Yeah, that's for the first one, the first
Okay.
vector. They're talking about
Oh,
the
oh
one, the
yeah, up
two,
here
the fives.
instead
Yeah,
of doing a poll. I
yeah.
gotcha.
So if you pipe it to table, you get that results, which is 52 ones, 30, 13 twos, etc.
Gotcha. Yeah, that's a good way to look at it too.
Yeah.
Table and then like I'm sure you can do like uh some type of plot as well to like make it easier to understand.
Yep.
um and especially with this as well, especially since there's so many different numbers of hitless streaks, um which he actually does that in a way, for out his out streaks. We get a table, or well, maybe not a tibble, I should say, um, where he does have a few longer streaks, with 10 or more hitless streaks. Let's see. Oh, so we have his streaks, and this was similar to what we did with DiMaggio. Then we'll actually take a look at his performance over a 30 at bat window instead of the game window we looked at with DiMaggio. So this is similar to above. We'll look at where he got a hit at the bottom, and then we'll plot his moving average. So here, with the rolling at bat window, you can see there's much more, I guess, streakiness involved. Um, I'm sure if you change your window, you'll see it fluctuate more or less depending on how large the window is. Um, but there are points in his season where he batted well above his final average, and uh, you can see where he got those hits as well. And then yeah, after this hot period, he cooled off for a bit as well. We can do that for all players as well. Um, from the book, we create a new function called longest offer. Um, offer being no hits in X amount of at bats. It's common to say 0 for 4, 0 for 3. So that's basically calculating the longest time you go without a hit. So we'll take a look and just make sure that this works for Ichiro. It indeed shows his longest streak of being hitless is 18. Um, and then we take a look at all batters for 2016. with 400 or more at bats. Here we're just we're gathering that data and filtering it based on the at bats. And then we join with the lawman data set to get their actual names from the batting ID, and we take a look at the top, or I guess the bottom players of the longest streaks. And compared to Ichiro, these are a little more. Carlos Beltran, his highest peak was 32 at bats. Denard Span, Brandon Moss, Eugenio Suarez, Lindor, and Albert Pujols. Yeah, this definitely feels right for like the maximum hitless streak. I would be curious to see like how this number compares year over year. I think, yeah, we filtered for 400 more or more at bats. Like if yeah, if we're looking at 32 of those like 400 at bats, that's getting close to like, well, not quite 10% of the season, maybe like 7% or whatever. So that's not a small portion of the season. So yeah, it's interesting to see uh, how Ichiro compares to those to the other folks as well. Um, so here in the last part of this section, uh, we take a look at um, Ichiro along with Mike Trout. Um, Mike Trout is he's still playing. Um, really good baseball player. And this season, he accumulated over 10 wins above replacement. So we'll take a look if either of these batters were especially streaky. Um, I may need. I'm not sure if I completely understood this section, so I'll try to explain it the best I can. Maybe you all can help chime in as well. But here from the book, one good measure of streakiness, or they could say clumpiness in the sequence, is the sum of squares of the gaps between successive hits. And so if they gave an example of like 13 at bats, 0, 1, 0, 0, 1, 1, 0, 0, 0. The sum of squares would be like, I think it's 1 squared plus 2 squared plus 4 squared. And so yeah, to illustrate this method, consider a hypothetical player who bats 13 times with these outcomes. If the player sequence of hit slash outcomes is truly random, then all possible arrangements of the sequence of 6 hits and 7 outs are equally likely. So they randomly arrange the sequence. This randomize it again, randomize it again. Each time we'll find the gaps, compute the streakiness, so that sum of squares, 1 squared plus 2 squared plus 4 squared. I think this is correct. And then that randomization procedure is repeated over and over and over again many times for example, doing it 1,000 times. And then we compare um, that randomization to what actually happened to see if it was streaky. So in this case, we take each of those at bats. We get his streaks and filter for his hitless, and then get his sum of squares and get a number of 1532.
To elaborate on this, I as a person who majored in math and such, I did find this sum of squares part fairly intriguing, and that's what set me off onto Google searches that led me back to Jim Albert. In particular, I was wondering, like, has this sum of squares technique been a fairly standard technique where else has it been used? And like I said, it turns out that the other person that used this was Jim Albert himself, at least in my initial Google searches. From what I can tell, the motivation is in the squares themselves to give more weight to the longer streaks. So a streak of
Mm.
2 is 4 times as valuable as a streak of 1. A streak of 3 is 9 times as valuable as a streak of 1, etc. Then from there, as Trevin just described, it's a pretty standard permutation test, which is how hypothesis tests should be carried out nowadays through computer simulations and such. But otherwise, I think that's the background mathematics of it.
Oh, interesting. Thank you. Yeah, that helps. That helps figure out, or at least understand the the why a little bit more. Um, I can go back to the book too. Let's see. Yeah, so this is the calculation here for the example, and then just their example outcome as well. So in order to understand if this is streaky or not, we create the random mix function, which takes that, uh, samples it and rearranges it, and calculates uh, a new sum of squares. So we do this 1,000 times using the per package, and we plot the results along with Ichiro's sum of squares that we observed. And then here we get the histogram, or the frequency of all the sum of squares, and the observed number as well. So here the book exclaims or explains that this is streaky. And then we find the quantile too, just to hammer that point home. I think it's 90% is what it was. Yeah. So yeah, definitely shows signs of streakiness. We do the same with Mike Trout, and in order to do that, basically we do the same thing, but we just create a new function for this, given a certain player ID. And this is a plot that we come up with. So was Mike Trout considered streaky in 2016. And since what we observed is on the left side of the histogram, he was not considered as streaky as Ichiro. All right. In the remaining time, we'll take a look at StatCast patterns with launch speed. I actually was just able to download the StatCast data this afternoon. If you haven't done so already, you can find out how to do so in the chapter 12, in chapter 12 of the book. So we'll read in the StatCast data, and then I think these are hits, or I'm not sure, but we get the launch speed for each player, and we're filtering it by players, I think over 250 at bats. And then I think I'm not sure if I understood this correctly, but we created a new function to basically create bins for each part of a season. So instead of looking at windows with our hit streak and our at bat windows, we take a look at different parts of the season. So specifically, group size would be, for example, 5 would be games 1 through 5, and then games 6 through 10, and then so on and so on. So we have a new function to do that. And then specifically, we'll take a look at the batter AJ Pollock's data. Interesting. This, I don't think ran.
Yeah, Trevin, when I ran that code,
Yeah.
I had to change the name. Okay.
Oh, this.
Yeah.
Okay.
Yeah, I had to change it to this. Last name and then the
okay.
name. Okay, because they changed it for some reason.
Yeah, that must be that must be how StatCast changed it on their
Yep.
end. Okay.
Okay. So if you
Yeah.
do that, you should be fine.
Thank you.
Yeah.
I
I found the
just got
hard way.
I just got the data to download like 10 minutes before this. So
Yeah, that's okay.
so yeah, if once you do have the correct filter on, I'll just go over here. We see each group of 5 games and his sum of launch speeds as well. So then
Also, in that list, I remember that I was getting some NAs, okay, some missing values.
yeah.
So what I had to do, I didn't quite get the numbers, they're very, very close. But what I had to do is when I read the StatCast 2017, I had to drop in the launch speed, I had to drop those NAs. Okay.
Oh,
Because
okay.
apparently something happened that they didn't record it. Okay. So
Yeah.
what I did was, dropping, and then everything is going to be running fine.
Okay.
So those are two changes that I had to do to the code to make it running, because I remember that I was getting an 8 in the first bin, and I said, well, what happened here? And then I start backtracking and found out that there were an A's in launch speed.
And that was NA launch speed for like when there was a hit.
I know that there's so many A's. If you look at
Okay.
the first records of the Statcast, you check launch speed, there's so many A's there.
Okay.
Okay. And because we're filtering right by the type X, I think, or something. Yeah, the type X, for some reason, some of those records contain those NAs. Okay, so
Yeah.
what I did was drop them and work with the with the records that had a value there.
Yeah. Yeah, that's good.
Okay.
Okay, yeah. So yeah, make a note of that, I guess. I suppose yeah, taking them out would be good. Um Maybe I'm not sure like if there would be some reason you would want to keep them, like maybe you would insert just like the average launch speed instead. Like I don't know, maybe there's a given reason you would do that. But yeah,
Yeah,
make it
just for trying to get the the simplest
yeah,
possible thing, I just drop them.
that makes
And
sense.
they're not that many, they're just I know they're just a few of them that will cause
Okay,
that way.
thank you.
Yeah.
Um, so I'm sure that's the case for other people as well. Make a note of that. Uh, Interesting. Uh, I'm not sure. It looks like we remove NAs here, and I'm not sure if you had the uh, same thing with this function, but basically we're creating a new function to do the same thing for a given player, with the group size defaulting to 5. Using our new function, we find AJ Pollock has an average launch speed of 88 miles per hour with a 3.44 standard deviation. We apply that to the whole list of players with 250 at bats, and plot it using ggplot. Yeah, I'm not. Here's Michael Conforto. Wait. Oh, we highlight a few players. Is that yeah? So people that have a high standard deviation, Trevor Story and Michael Conforto, and then players that are pretty consistent in their launch speed as well. And then I'll have to figure out why this part of my code also didn't run. But we take a look at specifically Conforto and Dexter Fowler, creating a new function, streak speed, to take a look at their average speed over a given game window. And then plotting this out, we can actually see what makes Dexter Fowler so consistent in his launch speed. And we can see the streakiness of Michael Conforto. And that's the end of the Statcast section. There's also further reading, but the end of the chapter, along with the exercises as well. I didn't get to any of the exercises. I guess something else that I would be interested in, and I don't think this is in any of the exercises, but just taking some of the maybe some of the new StatCast measures and seeing if you can like just see different ways to view player streakiness performance. There's a lot of new metrics out there that have been recently launched. So I'm sure you can get you can compute like consecutive like good at bats or something. That would be interesting to me. But anyway, I will leave that exercise to the readers. I'll leave these exercises to the readers as well. That being said, are there any questions or comments from this chapter?
I think the only comment I had was that when he was talking about this, whether or not the streakiness was unusual or not for those two players, were those just those weren't randomly selected players. So I don't know if they were already expected to be streaky, in which case maybe they weren't, or not streaky in one case and streaky in the other case. Or these just like two players with interesting names, or do you remember?
For which section?
We know the little histogram, the line on there is trying to convince us that, oh, that's pretty streaky. But
Yeah, when it's
like,
comparing the Ichiro and Trump.
yeah,
Oh,
Ichiro, yeah. So
yeah, yeah.
Ichiro is saying, okay, why do you choose Ichiro? Well, is he somebody that is
So
there's like a
my
little
guess,
bias there I was worried about. That's what I was trying to get at, you know.
I think Ichiro was getting older by that season, but especially in his earlier years, he had very high batting average. So he would be, you would assume he would be like pretty consistent or less up and down and streaky.
Okay, cool.
And I guess the same thing with Mike Trout as well, especially he was more in his peak, yeah, in those years.
Mhm.
Yeah, fourth in MVP votes for 2017.
I'm just not sure if I should consider 90th percentile to be that convincing that he really was streaky or just random chance. You know what I mean? Well,
Yeah, that's
1 out
fair.
of 10 is not that hard to believe. Like, well, okay, if you pulled the random player out and clearly at 1,000 shuffles, 10% of them were higher than that. So that's not that convincing to me. Right?
Yeah, that's fair.
Also, maybe we can get from this that streakiness doesn't mean that the play is, is good or bad. Okay, you can be a consistent player. Don't have that streakiness.
Well, my point, I guess,
deliver, right?
what I was trying to get to is the idea that people like see streakiness, like because people tend to see patterns that might just be
Right.
random. It's like, wow, that guy, been doing so well, but like it just happened to be luck, whatever, right? It's like, if you go to Vegas, you like look at the roulette table, they'll have like a screen up there. I'll show like all these reds in a row, and everybody's, wow. It's like, well, it's clearly random, but you're seeing, occasionally there'll be a lot of reds in a row. Like sometimes you can see like 10 in a row. It doesn't mean that the roulette table is having a red streak. I mean, it is, but it has
Right.
no significant meaning. It doesn't mean anything special about the roulette table, or maybe it doesn't mean anything special about the baseball player, right? It does have some effect, of course, on the baseball player, right? Because that they get what they call the yips or whatever. There tends to be this effect where you're playing poorly, you get inside your own head and you play poorly more, right? So I would love to see more study of that. Like, is that a real effect or not? I'm not sure, right? I wasn't convinced by this chapter that was a real effect or not, but
Yeah, to your point, I was just looking up those three players that were identified as streaky in one of those last graphs. Dexter Fowler, as you can imagine, tail end of the career. Trevor Story, that was actually it was his second season, kind of a sophomore slump, a dip. I would suspect he probably was working through an injury. And on the other hand, Michael Conforto, that was one of his better years. So this is actually a quick lack of correlation between streaky and performance.
Right.
Don't they use that sophomore slump too as like a kind of example for regression to the mean type phenomena where you picked up the player while he was hot because he's hot, but then sometimes just there's unusually hot that year, so they tend to regress down to the mean. Wasn't that? I think I've seen that used as another example of a kind of fallacy of statistics type thing. It's really easy. I'm always cautious about it because it's so easy to fall into these fallacies, right?
But there might be some causation when you're moving
No, there is.
from
That's true
120
too.
games to 160 games.
Yeah, I agree. There could be causation. It's just that correlation is not causation, right?
Right.
Yeah, you need a control for these things somehow. I don't know how you do it, but yeah.
I think also there's maybe not as much maybe there's not as much research specifically for like baseball and the streakiness, but I feel like similarly like the hot hand effect, like
Yeah.
for basketball is like similar as well. Yeah, I feel like there's a lot of research for that. And a lot going back, like, is this real? Is this not? Yeah, I'm just linking the wiki articles.
Yeah. Okay, cool. Yeah, the hot hand effect is canceled out by the gambler's fallacy effect. Like, I always say that. I always tell people, like, no, look, at all these reds in a row. Red's hot. Oh, don't you mean blacks do? Which is it?
For another example of streaks, I think Rafael Devers started out hitless in his first 20 at bats this season. But at this point, up to the trade, he was the Red Sox best hitter.
Correct. Yep. Yep.
Very interesting, though.
Nice.
Anything else? Should we get ready to adjourn? It's almost out of time anyway. So yeah, look forward to Ricardo next week, taking over for the park factors, which is something I've always been curious about. So I'm looking forward to hearing more about that.
Yeah, very interesting topic. Yeah.
Cool. Anybody have anything else to add before we adjourn?
I think we're good for the next 2 weeks. Is that correct?
Yes. Yeah. 2 weeks, and then there's a gap. I'll fill that in if no one else does, but I'll just leave it open for now. The home run hitting chapter 13.
Cool.
All right. Cool. All right, guys. See you next week.
All right.
Yeah.
Thanks.
See you everyone.